Now let's talk about direction briefly. Direction is really pretty simple. For some of you this will be a new concept. For others of you who are used to compass and orienteering things, it won't be. But there's two different sets of direction we can use, and we'll use in this course, and you need to be familiar with both. Why? Because they both have practical applications. One is a set of math directions or coordinates on the coordinate grid, and the other is a set of map or navigational directions on the coordinate grid. Okay? Let's look at the map or navigational ones first, because they will make more sense. When you put down a map to the top, okay, in front of you is typically going to be north or 0 degrees or 360 degrees, whichever one. If I come to the right and I go clockwise, at the x plus axis, positive x-axis, it will be 90 degrees. At the negative y-axis, it would be 180. At the negative x-axis, it would be 270. And we come back to the positive y-axis to 0 and 360. So basically what you're looking at is in front of you is north, behind you is south, to your right is east, to your left is west, is what we're talking about. Okay? And so that's an orientation you need to get used to. We're going clockwise. Now the math orientation is a little different. It starts at the positive x-axis and it goes counterclockwise. So the positive x-axis is 0, 360, and as we go up, the positive y-axis is 90. We say plus 90, but it's just 90. And the negative x-axis would be 180 degrees, and the negative y-axis would be 270 degrees, and we come back on around to 0 or 360. Okay? So two different orientations. Now, what orientation we're going to use in this classroom? I don't care which orientation you use. If you're doing navigational vectors, it would be preferable that you would use the map and navigational directions. If you're using math type directions, it would be advantageous to use in math orientations. It would be advantageous for you to use this because that's what people are going to be used to. You may choose whichever one you want. However, you must explain yourself. If you're going to use math, you have to say math directions and put the direction on there. If you're going to use navigational, say navigational and put the direction on there. That way we know where you are. Because 90 degrees in the math direction is totally different than 90 degrees in navigational. They're 90 degrees out of sync. 0 degrees and 90 degrees out of sync. So you have to tell us what you're using. That is the directions we'll be using. Now let's figure out how we calculate that direction. So let's look at a little bit of how we would determine direction on this. Let's take the vector we were talking about. Vector EF in component form, it is 6, -1. Let's graph it on here. We know that, okay, we make a little box out of that. We know that the lengths are 6 and the widths are 1. Now let's blow that thing up over here and have it here. This is 0, 0. This is 6, -1. What do we got here? Well, we've got an angle alpha if we're here. We're looking down this way. Or we've got an angle beta. So if we're coming from the positive x-axis, we've got angle alpha. If we're coming from the negative y-axis over here, we've got angle beta. Well, we know that the tangent of alpha is equal to opposite over adjacent, or 1/6. So therefore, the inverse tangent of 1/6 is going to equal our alpha angle. We need to find that angle. And when we do that calculation, the measurement of angle alpha is going to be what? Well, it's going to be 9.46. Okay? Now let's find out what the angle beta is. You can do the same thing. The tangent of beta is, what's the opposite? It is 6. What's the adjacent? 1. So the tangent of beta is 6 over 1. Therefore, the inverse tangent of beta, 6 over 1, is going to yield us an angle of 80.54. Okay? So that's 80.54. Add those two together, what do we get? Well, we better get 90, haven't we? Yeah, we have to get 90. Okay? So what we know is, we know that if we're coming off the positive x-axis, we've got 9.46 off of that positive x-axis in the downward direction. We also know that if we're coming from the negative y, we've got Well, it depends. We're in a clockwise coming off the positive x-axis. If we come off the negative y-axis, we're in a counterclockwise 80.54 degrees there. Okay, so now we've got our degrees. Now let's play with what that looks like on the math coordinates and what it looks like on the navigational coordinates. Okay, let's look at this on the math coordinates, what we've got over here. Okay, if we take the information we've developed over there and we come up and we look at our math coordinates. Now remember, the math, it being in the blue, starts at 0, 360 over here, okay? It goes to 90 at the positive y, goes to 180 at the negative x, and 270 at the negative y. So if we start and it goes counterclockwise. So we want to know what direction that is on the math coordinates. Well, we would start at the positive x, which would be 360 or 0. Prefer to start at 360. We would subtract what? We would subtract our alpha from our 360, okay? And we would get, that is at 350.54 degrees math coordinate. Or we could come around and go, oh, I don't want to go backwards on this. I want to go forward. Well, where are we coming forward to? Well, this axis right here is 270 degrees. So we could start at 270 degrees and we could add our what? Okay, this being the positive or the negative y-axis, we can add 80.54 degrees. When we add those two together, well, we better get the same thing. Why? Because that vector is headed the same place. Hadn't changed. So sure enough, it doesn't matter which direction we come, whether we're going clockwise off of the 360 or we're going counterclockwise off of the 270, we're going to come up at the same place. That vector is headed the same place at 350.54 degrees. Now, let's look at it from a navigational standpoint and using navigational directions. Okay, now let's take the same problem we got and the same angles and let's look at how we would represent it on a map or navigational. We calculated that alpha was 9.46 degrees and angle beta was 80.54 degrees, and we're all looking at the same thing. This thing hasn't changed anything. It doesn't matter what set of directions we use. This thing is still headed the same way. It hadn't moved any, okay? So map degrees, we notice that positive x is 90 degrees because we start at positive y, come down positive x is at 90 degrees, and we go clockwise, and so we would add what? 9.46 degrees to 90, and we would come up with, wow, we have a heading, an azimuth, a direction of, or a bearing of 99.46. Okay? Navigational heading. Bang, I know exactly where you're going, a little what? Or we could say that we are 9.46 degrees south of east. Well, 90 degrees is east, we're going what? 9.46 degrees south of east is what we're headed. Okay? Or we could say, hey, I don't like that one. I would rather say that we're going east of south by what? Well, what's our beta? Our beta is 80.54 degrees, so we can say, hey, we're going 80.54 degrees east of south. So south is this way. Oh, we're headed that way. Okay? Now, all of those descriptions say the same thing. They all say, guess what? This vector is a 6, negative 1. Vector EF is a 6, negative 1 vector. Boom! All of that information is contained right there. All of this is contained right there. Okay, now you begin to understand how powerful vectors can be. In one little small representation of numbers, we have all of this information, okay, on all these calculations. It's a busy board. You need to study it. How do I get these angles, alpha and beta? From what position do we get them? Which one do you need to get? That's up to you. How do you want to describe it? How do you want to use it? All of that is going to be up to you. We'll do a lot of these samples in class and go from there if necessary. I'll put up a samples clip and video. But these are the basics of how we take care of vectors. All right? Welcome to Vectorland.